Good morning, world. This is Johan Bradley, and this is GAINSCITY News. So in other news, bros, we got some dude, and he's benching like 800 pounds up in the weight room. You know how it goes. And yeah, so like the Olympics are coming up here. Apparently, it's gonna be a little harder than what it was before, cause like the gravity's 35 meters per second squared. So gonna see some changes in how people compete. So yeah, I mean, let's just get to the brofessor, and he'll get right on it.
Saw, dude. My name is Dabber Bradley. I got a degree in weightlifting and pickup lines for girls at the University of Gainscity in Gainscity. And yeah, so I was kind of instructed to like tell you guys about how the Olympics is gonna be at Gainscity. It's gonna be a little different, as you sure they already said. So let's get cracking.
Alright, bros, so here's the deal. We got like Gainscity right here. It's like what we look like. And yeah, so the mass is 2.752 times 10 to the 27th kilograms. So we've been gaining some weight. It's gaining season. And the radius is 45,000 miles, or in meters, that's 724,204,80 meters. The distance from the sun is 30,000 miles, or 482,80320 meters. And the gravity on Gainscity, I just calculated it out because, like, why not? So I got like a formula right here. It's G equals GM R squared. And that just breaks down to that because G equals 6.670 times 10 to the negative 11. M is actually the mass of our planet divided by R squared, which is the radius of our planet. And yeah, that comes down to what I was talking about earlier, where our gravity is 35 meters per second squared. And yeah, so the period around our galaxy on how we orbit the sun is equal to T equals 2 pi times the square root of R cubed divided by G times M. And that comes out to T equals 2 pi times our radius cubed, that value, times the G value previously mentioned, times the mass of the planet. All that equals T equals 3.959 times 10 to the 30th seconds. So that's the seconds it takes to go around the sun. And yeah, so bros, almost forgot. So yeah, the reason why we use like that G, that like capital G that we used in this equation right here, is because that's the universal gravitation constant. So yeah, it's pretty important. I think so. So yeah, keep going. Alright, see you guys.
Alright, bros, let's get into the real talk about like why we're here. We're gonna talk about the Olympics, or pole vault, as they say, So yeah, let's get into how it's gonna be different here on like Gainscity. So I'm sure all you bros know that like kinetic energy, which is like KE, equals 1/2 mv squared. And then you got your U, which is potential energy. But in this case, it's going to be the gravitational potential energy. So what we can do in this, we can actually set those two equal to each other and have 1/2 mv squared equals mg delta H. And yeah, so what we can do here is we can solve for delta H, which is height, obviously. And that equals 1/2 v squared divided by g. Those two masses will cancel because those are like light terms and stuff. So yeah, we got our little pole vaulter here. If you guys haven't seen pole vault, the point is to like get over the bar. Duh. So yeah. So right here we're gonna give an example. So we got this dude from like France. His name's Renard Lavalline. Can't even say his name right because it's stupid. And yeah, he's the world record holder on Earth for pole vault. He jumps like 21 feet, which is 6.4008 meters. His velocity actually at that jump was 11.206 meters per second. So like, let's see how that works for Gainscity. So what would happen now is we just plug in literally all the variables. So let's just say in like a perfect world, he's running that same speed on his jump in Gainscity. So he's running at 11.206.
but that's going to be divided by 35 instead of like 9.81 or like how they do on Earth in AP Physics where they round to 10. No, we're going to be doing 35. And because of that, he's actually going to be jumping 1.794 meters or 6 feet, which is like garbage, bruh. So yeah, that's pole vault. Alright, bro, so we're going to move on to the second event, which is long jump. And like, if you guys don't know what long jump is, like, so this dude runs like 100% at like this sand pit, and he jumps on this little like bar thing, and he lands in the sand, and they measure how far he goes. So he gets that like velocity in the y and the x direction. So like, to make it like easier for your bros, this is kind of like projectile motion in a way. So like, the formula expressed in this is going to be like distance equals your velocity in the forward direction times the hang time in the air. So it's kind of like, you know, like delta x equals vt. So what we're going to do here, we're going to talk about my boy Jared Pryor. Honestly, I don't even know who this dude is, but I looked him up. He seemed pretty dope. And on Earth, his hang time and everything is 0.734 seconds. And his forward velocity was 8.72 meters per second. And yeah, he actually jumped, ironic enough, the same amount of distance as my boy pole vaulter jumped. And yeah, that was on Earth, so that's 21 feet. It's pretty good. And yeah, on GAINSCITY though, that's not the case, bro. So the increase in gravity will create a shorter hang time, therefore creating a shorter distance jumped. So like, he's gonna be garbage on GAINSCITY. Alright, bros, so let's look at like one more event, because I gotta hit the weight room after this. So yeah, high jump. Yeah. So if you ever done high, if you've ever seen it before, there's like this dude, and it's kind of like pole vault, except not as high because they don't have a pole. So yeah, they basically run and try to jump over a bar with just like their legs. And like a good equation, we'll use this because there's like a bunch of other variables to use. We'll use v squared equals 2gh, where v is velocity, g is gravity, and h is the height. So basically what this means is that the more speed, the higher the jump's going to be. Well, we can make that easier and just say like v equals the square root of 2gh. So let's talk about my dude, Javier Sotomayor. Yeah, I don't really know who he is either, but he like, I don't know, he has the world record, so that's pretty good. And yeah, he jumped 2.45 meters on Earth. That and they actually came at that jump at 6.933 meters per second. So like, I guess he was hauling it. And yeah, on GAINSCITY, baby, it's going to be a little different. So we're going to use that same equation, v squared equals 2gh, and we're going to plug in our numbers. So we're going to say that he's running at that same speed on GAINSCITY, just for argument's sake. And we'll say, and then we can just plug in our gravity, which is 35. So, and then we solve for h. And well, that h comes out to 0.687 meters. And that's compared to the 2.45 meters he jumped on Earth. So he's going to be jumping less high on GAINSCITY. So he's going to be garbage, bro, because there's more gravity. So like, yeah, that's high jump. Yo, thanks for that killer presentation, Dad Riley. I mean, it seems like that the increased gravity here on GAINSCITY from Earth is going to really have an effect on the athletes, you know? Like, we're not going to have, you know, the same numbers. It's definitely going to be less, it seems like, for the majority of the events. And I think we all have a good feeling of what to expect. So, yeah, this is Johan Bradley, signing off.